we said before we had an observer, right? And the observer is watching something that's rotating around. Okay? Let's call them the mover. Okay? So it's like someone starts here and then they're moving in a circular motion around. So I guess this is kind of like the stars, right? I know the stars aren't really moving, it's us. But you know, relativity, right? Actually, it doesn't matter sort of who you measure is moving. Okay? Alright, so the idea of a radian is to say, let's change the perspective from this guy and how much his head has to turn to follow the mover. Let's make this angle, let's make its measurement dependent on how far this person goes around. Okay? So if we've got a circle, so if I continued out this circle, if I continue, a circle of radius 1, okay, 1 unit. When that mover has gone the same distance as the radius, so if we call this arc length 1 unit. Okay. So I'm the mover, right? The reason why I'm calling it 1 unit is because the angle, right, will be the same no matter how large the circle is, okay? So this could be 50 kilometers and 50 kilometers, or, you know, 30 light years and 30 light years, okay? When we move 1 unit, we call that, you know, because it's 1 to 1, it's a ratio of 1 to 1, we call that 1 radian. Okay, 1 radian. Now you guys are smart. If you think about what happens from the observer's point of view, okay, if the mover went in a circular motion all the way around from one side, and you had to turn exactly around, do a half a revolution, right? So they're behind you. Okay, now. How far is this motion in terms of the radius? This radius here, right, is 1 unit. Okay. How far is that distance? What's the ratio between your radius and that half circumference? Yeah.
Is it pi r squared over 2?
Almost.
No.
We're talking. Pi r squared is about area, right? It's on the right track, right?
It's pi.
It'd be. P.
Pi.
It'd be pi times whatever your radius is, wouldn't it? Right? Because it's half the circumference. Right? So in this case, it'd be pi, right? That's how far they've gone around. Pi units. Pi times further than the radius. Okay? So that's why we call this angle that corresponds to that movement, right? We call it pi radians. Okay? Because that's how far the person has moved with respect to the radius. And of course, if they went all the way around, it'd be 2 pi radians because they've gone twice as far. Okay? Just a quick note as a side issue. I will always write pi, and I write the units as rad. Not just because I like radians and they're rad, but because the symbol for radians looks like that. It looks like a letter C. It kind of looks like half of the degree symbol. But it's so easy to mistake for a degree symbol that I just leave it off. And I'd rather write something that's kind of ambiguous. Okay? So that's why I write rad. Okay. So, let's pedal back a second, come back over here. Okay. This is why, if we're going from the perspective of the mover, we define 1 radian as, do you remember what the definition for 1 radian is? 1 radian is, okay, it's the size of the angle, or the magnitude of the angle, or it's just the angle, that, now, mathematicians use this weird, awkward word. I don't know why they use it, because no one uses it in English. And there's a perfectly good synonym for it. They use the word subtended. I prefer the word formed, or made even. 1 radian is the angle that's formed by an arc, right? That arc, equal to the radius of the circle. So even though I don't have a full circle here, I'm implying one because that arc there can only go through a single circle, right? There's no other circles that could pass through that arc. Okay, now I think from memory, this works out to be, if you're trying to translate back to your old system, okay, I think it's like 57.3 degrees or something like that. which is more than 45, which is why I knew I'd drawn mine a bit small. Okay, but that's about how far you have to go to make the radius equal to how far you've moved as the mover, or how far things have rotated. Okay. So now that we have this idea of measurement, that's where all of the other formulae for measuring circular quantities comes from. Okay, so let's think about an arc. If we said here 1 radian is 1 radius around the circumference, right? That means that the length of the arc, okay, is just your radius. In this case, it was 1 times how far you traveled around the edge as an angle, which is just 1 radian, right? In this example. Okay. If it was 2 radians, I would have gone twice as far. So you see how this makes it much easier because we're thinking about the perspective of the mover to work out distances like this, right? So that's arc length. Okay. What about the area of a sector? Well, if we're thinking about the area of this thing, the area of a circle, the whole thing, right, is pi r squared. Yes? But I know that that's the whole circle. What's the angle that makes up the whole circle? How far do I have to go around? 2 pi, right? So another way you could write this is half times 2 pi r squared, right? Because 2 pi is going all the way around, okay? Now if I don't want to go all the way around, if I just want to go, say, theta around, maybe it's just 1 radian or 2 radians or whatever, okay? I will take area of a sector. Not 2 pi, which is the whole circle, right? But just whatever angle you've got. Okay, 1 radian, half a radian, pi radians, and then I'm still multiplying by r squared. So of course we don't usually write it like this. We usually put the theta on the end. Okay. All right, now, if you wanted to know, because I don't know why you'd want to know, but if you wanted to know what this part is, right? What shape do we call that, by the way? That's a segment. If you want to know the segment, you start with the sector, right? And then I'm going to subtract something. So the sector is this part, half r squared theta. What do I have to subtract? I have to take off this triangle, yeah? Now, there's lots of different ways to express the area of a triangle, but based on what we know, I'll know the radius of this circle, and I'll know the angle, because I already know this angle, right? So when you know sides and an angle, right, we say the area of a triangle is half AB sine C. Who's that? Ringing bells? Yes? Not slowly. Okay, good. In this case, A and B are both the radius, right? They're the sides around the included angle. Okay? So they'll be half R squared. Okay? And of course, C, the included angle, is the radians that we've been talking about. That's the theta, right? So sine theta. Okay? And of course, that's why you can take out a factor, and here's what you get. Okay? Now, by the way, can you see, this is why this formula only works in radians, not in degrees. This always puzzled me, because I thought, if the difference is just units, surely I can use whatever units I like, right? It's not like the area of a circle. It's like, this only works in centimeters, doesn't work in meters. Sorry, guys, okay? Why? Because this number here, this theta, right, is about a distance moved around, okay? If you change it to degrees, at least this part, you're talking about this guy turning his head around, which is a completely different measurement, right? I want a length around the circumference, not a guy spinning his head or a sailor following the stars, okay? So there's your formula, all right? And that's all of your radian measure formulas in a nutshell and where they come from, okay?